Hello, Year 10. Today we are doing applications of parabolas. So we have learnt many skills to help us sketch parabolas. We've learnt factorizing, we've completed the square, we have used the quadratic formula and the discriminant. We've used axis of symmetry formulas, all sorts of things, lots of techniques to be able to sketch parabolas. This exercise is all about ways that the parabolas that we've been studying can be applied to more practical situations. So each question is a little bit different. So you will have to adjust as you go, but you will be using all the skills that we have learnt in the previous exercises. So question number 1. We have an 80 centimetre piece of wire that is bent into the shape of a rectangle. Let X be the width of the rectangle. So I'm going to draw that in here. I just like to have a little diagram. Here's my rectangle, and the width of that rectangle is X. In part A, it says, use the perimeter to write an expression for the length of the rectangle in terms of X. Now the width was X. The length of my rectangle, I'm going to call that Y. So there's the Y. So for the perimeter, I would have 2 X's and 2 Y's. That would be the perimeter of that rectangle. And we know that the perimeter is 80 because it was an 80 centimetre piece of wire. To make this equation a little bit nicer, I'm going to divide everything through by 2. So that means that X plus Y is equal to 40. And I was told to get an expression for the length in terms of X. That means I want the Y by itself. So move the X over to the other side. Y is equal to 40 minus X. So instead of having Y, this side length here is 40 minus X. So I have the width and the length both in terms of X. I don't need Y anymore. Part B, write an equation for the area of the rectangle. The area of a rectangle is always base times height. The base and height of my rectangle is X times the 40 minus X. You could expand that out, but it's actually easier to have that factorized. So let's leave that like that and move on to part C. Decide on suitable values for X. If my area were to equal 0 in that previous expression that I've made in part B, I would be able to use null factor on the factorized quadratic that I have there. And I would get from the first X out the front that X is equal to 0. And from the bracket, I would get that X is equal to 40. So my suitable values for X are that X needs to be anywhere between 0 and 40. So the 0 comes from that one, and the 40 comes from that bracket. And anything in between would be fine. If I went outside of that, if I went to say X was equal to 100, it would give me a negative area. And you can't have a negative area. You can't even really have a 0 area, but we'll allow it. But anywhere between 0 and 40. Part D. Sketch the graph of A versus X for suitable values of X. So, from the equation that we've worked out up here, the x-axis is going to be right down the bottom here. Because remember, I'm not going to have any negative values. So I'm really just graphing in the first quadrant. X is the horizontal axis, and we're going to have A on the vertical axis. We have said that suitable values of X are between 0 and 40. So I'm going to go 10, 20, 30, 40. That's as far as I need to go for my X values. So my parabola is going to start at 0, and then it's also going to end at 40 because they were my x-intercepts, which I was working out in part B. What I need to know is where the turning point of my parabola is going to be. To do that, I already know my x-intercepts, so the turning point will be right in the middle. Between 0 and 40, the middle is 20. So if I sub in when x is equal to 20 into this equation, the area is going to be equal to 20 bracket 40 minus 20, which is equal to 400. The maximum area is 400. So I'm not going to, again, not to scale, but 400 is going to be up here at 20. It'll be at 400, and my parabola is going to come down like that. Okay, so I'm just going to label this turning point 20, 400. Part E, use the graph to determine the maximum area that can be formed. The maximum area is that turning point. It is the y value of that turning point. The maximum area is 400, and the units were centimetres, so it's going to be centimetres squared if it's area. What will be the dimensions of the rectangle to achieve this maximum area? So if the 400 is the maximum area, the dimensions that give you that are when x is equal to 20. So we know x is 20, but looking back at my rectangle, if x is 20, the other side is 40 minus 20, so it's also 20. It's actually a square. So this is going to be a 20 centimetre by 20 centimetre square that would have the maximum area. Only at the maximum is it a square. If you went to any other point, it wouldn't be a square. All right, on to question 2. The path of a javelin thrown by Joe is given by this equation here, where h is the height in meters of the javelin above the ground, and d is the distance horizontally that it has travelled. Sketch the graph of the rule from 0 to 22 by finding the intercepts and the coordinates of the turning point. Okay, so if I want to find the x-intercepts, we would start by subbing in when d is equal to 0. It's actually d, I should be doing d and h, not x and y. So I'm going to sub in when d is equal to 0, which will give me the h-intercept. So that would be h equals minus 1 over 16. D is 0, so 0 minus 10 squared plus 9. In the calculator, that equals 2 3/4. I'm also going to sub in when h equals 0. So this is like when x is 0 and y equals 0 to find all the intercepts. If h is equal to 0, we're going to get minus, so 0 equals minus 1 over 16 d minus 10 squared plus 9. If I move the whole bracket with the minus sign over to the other side, it will make it positive. So a positive 1 over 16 d minus 10 squared is equal to 9. Times the 16 over to get rid of the fraction. 9 times 16 is 144. Square root, and we get plus or minus 12. Then move the 10 over, we get a positive 10 plus or minus 12, which means 10 plus 12 is 22, or 10 take away 12 is minus 2. The turning point is going to be where we have to find our turning point. We have got our two x-intercepts at 22 and minus 2. So if we were to average those, 22 minus 2 over 2, that would be 20 over 2. It gives us 10. Then you would need to sub 10 back into your equation. So you do this in your calculator. I'm running a bit of room here. So in your calculator, you would put the 10 into this equation up here. So minus 1 over 16 bracket, 10 minus 10 squared plus 9. Oh, that means it's just going to be 9. So 10, 9. So I've done that with the intercepts. I could have just done that from my turning point form because that equation is in turning point form. So 10, 9 comes straight out of that equation. Then I can draw this. I have got x-intercepts at -2 and 22. However, I was told to only sketch between 0 and 22 because you can't have a negative distance in terms of how far you've thrown something. So we're going to start at 0 and our other x-intercept is going to be at 22. The turning point is at 10, 9, so it's going to be up here somewhere. And my parabola is going to come down, and its y-intercept, which is actually the h-intercept, is at 2 3/4. So it comes down, and that intercept there is at 2 3/4. So that this axis is the D, this axis is the height reached, and I've only sketched between 0 and 22. All right, what is the maximum height that the javelin reaches? So looking at my graph, the highest point is when y is equal to 9. So that is my maximum height, 9 meters. Part C, what is the horizontal distance that the javelin travels? So it's actually starting off the ground. So maybe that's a very tall person, 2 3/4 meters, or maybe they're standing on something. But it's starting at that height, but horizontally it is traveling 22 meters. And that is it. All right, time for you to look at exercise 9F.